Welcome back to the Deep Dive. This is where we cut through all the noise and get straight to the insights you really need to be truly well-informed. It's fantastic to have you with us.
Great to be back.
So I hope you managed to catch our last deep dive. We went into Pharma 5.0 and 20 incredible Gen AI ideas.
Oh, that was a fascinating one.
Absolutely, yeah. Exploring how generative AI is just completely revolutionizing, drug discovery, personalized medicine,
Yeah.
even clinical trials.
The applications were really quite something. Mind-blowing, actually.
They really were. It just shows how powerful this tech is, across totally different industries.
Exactly.
So look, if you haven't explored that crucial topic yet, or maybe you're new here and want to keep up with these cutting-edge insights,
You definitely should.
we'd love for you to subscribe. You can find us pretty easily on YouTube. Just search for @CAIOZone, that's CAIOZONE, or CAIO Playbook.
You'll spot our logo.
Yeah, you'll know it's us. And we're also right there on Spotify, same identity. We really want you to be part of every deep dive we take, stay ahead of the curve.
Indeed, and staying connected to these technological currents is definitely more important now than ever, I think.
For sure.
We're just seeing such a rapid acceleration of innovation, and the pace, well, it demands constant attention, doesn't it?
It really does.
So today, we're shifting our focus.
Yeah.
We're moving to an industry that is quite literally built on connection. Telecommunications.
The backbone of everything digital, really.
Precisely. This sector is always right there at the forefront of technological change, and what we're about to discuss today suggests maybe its most profound transformation yet.
Okay, intriguing.
And we're incredibly lucky today. We're diving into the insights of Ajit Mishra.
Right.
He's a true veteran of the telecom sector. I mean, his career spans decades, working with all the major players. Think Verizon, AT&T, BT, Airtel, Vodafone, Idea, Reliance, BSNL. The list goes on.
Wow, so he's seen it all, basically.
He really has. That kind of experience gives him this unparalleled, deep, practical understanding of the sector's complexities. He's watched it evolve through multiple generations firsthand.
That perspective must be invaluable.
Absolutely. And what's truly compelling, I think, is how Ajit Mishra views generative AI. He doesn't see it as just, an optional add-on or some incremental upgrade.
Not just faster pipes.
Exactly. He sees it as the core driver for a sixth revolution in telecom, what he confidently calls Telecom 6.0.
The Telecom 6.0, okay.
Yeah. He foresees generative AI not just improving existing processes, but as a fundamental systemic transformation.
Huh.
Across everything: network optimization, personalized customer experience, sophisticated fraud detection, and even the very backbone of operations.
You mean like OSS and BSS?
Exactly. The operation support systems, OSS, and the business support systems, BSS. It touches everything.
Okay, let's unpack this then. Let's get to the heart of it. So our mission today is to journey through Ajit Mishra's visionary insights. We want to delve into exactly how generative AI is poised to redefine the very fabric of telecommunications.
Redefine is the right word.
Yeah, we're not talking minor tweaks here. We're talking about a complete rethinking, right? How networks operate, how we interact with them, how the industry delivers value.
A fundamental shift.
So we'll be looking at 15 compelling ideas that Ajit Mishra lays out. These aren't just going to incrementally improve things. They're set to fundamentally transform the sector from the ground up.
That's the potential, yes.
So get ready for some serious aha moments, I think, because the future of how we all connect is about to get a whole lot smarter, more adaptive, and surprisingly intuitive.
It's more than just speed.
Right. This isn't just faster internet. It's about a fundamentally different kind of intelligent network. All right, before we dive straight into the what of Telecom 6.0, let's maybe just quickly understand the journey that brought us here.
Good idea. Context is key.
Telecommunications has always been about these waves of innovation, hasn't it? Each one building on the last, pushing the boundaries of, what's possible in connectivity.
Absolutely. From the humble telephone way back when to these pocket supercomputers we all carry today. It's just a story of constant reinvention.
It really is.
Precisely. And if you look back, the evolution has been relentless. Each generation brought not just new tech, but entirely new capabilities that literally reshaped daily life.
Like night and day sometimes.
Exactly. We started with the dawn of digital communication and early mobile data. technologies like CDMA and GPRS.
Right, I remember those acronyms.
Yeah, those were the foundational steps, really.
Yeah.
Moving us away from analog into a new digital era where mobile communication first started to take shape.
Checking basic email on a phone felt revolutionary then.
It did. That was when you first started checking, basic emails or maybe super simple web pages on your phone. A totally novel experience at the time.
And then came the jump from 2G to 3G.
Right. And that wasn't just about, say, clearer calls. Crucially, it was the introduction of more robust mobile data capabilities.
Okay, so more than just talking.
Much more. This was the period that truly paved the way for the smartphone revolution. It allowed for, basic internet browsing, multimedia messaging, early app adoption, all on the go.
Right, the app stores started to appear.
Exactly. Suddenly, having a mini computer in your pocket started to become a real possibility. Then following that, 4G. That truly ushered in the era of high-speed internet and real-time communication as we know it now.
That felt like a massive jump.
It was. This is where we saw the explosion of video streaming, social media platforms becoming totally ubiquitous, and a whole new way of interacting digitally.
Netflix on your phone, video calls.
Think of how quickly Netflix and YouTube grew, and how real-time video calls just became commonplace. That was 4G at work, transforming how businesses operated and how individuals connected globally.
And now we have 5G.
And most recently, yes, 5G has expanded that horizon even further. It brought the advent of ultra-low latency.
Super responsive.
Right, enabling massive Internet of Things, or IoT, connectivity, and laying down the foundational infrastructure for future digital transformation.
So smart cities, automation.
Exactly. We're talking smart cities, advanced industrial automation, even things like remote surgery becoming feasible because of its speed and responsiveness.
Incredible potential.
Each of these generational shifts has profoundly opened doors to unprecedented possibilities, constantly setting the stage for continuous disruption.
Which leads to the obvious question.
It makes you wonder, doesn't it? What truly undoes a revolution in this space? And why is Telecom 6.0 different from these previous, really significant upgrades, which, let's face it, felt like revolutions themselves at the time?
That's a great question, yeah. Because we've seen so many next big things in telecom. So what does this all mean for Telecom 6.0? Here's where, as you said, it gets really interesting. Ajit Mishra describes it as the industry standing on the brink of its sixth revolution. And what makes it fundamentally different from all the upgrades that came before is its intrinsic intelligence.
That's the core of it.
We're not just talking about faster speeds or bigger bandwidth anymore. Those are almost like table stakes now, aren't they?
Absolutely. The core of Telecom 6.0 is its driving force. It's defined by the convergence of advanced technologies with generative AI at its core.
Okay, so AI isn't just part of it. It is it, in a way.
It's the engine. This isn't just an incremental upgrade like moving from 4G to 5G. It's what we're calling a quantum leap.
A quantum leap. Big words.
It means we are redefining the very fabric of telecommunications, moving beyond simply connecting devices to creating an intelligent, adaptive ecosystem.
Adaptive, okay.
And generative AI's unique capability to create, predict, and optimize complex systems autonomously that truly sets it apart.
How so? Different from regular AI.
Yeah, unlike traditional AI, which mostly analyzes and interprets historical data to find patterns or maybe make predictions based on known scenarios.
Right.
Generative AI can generate new data, new solutions, even new network configurations, totally on the fly.
Ah, so it creates, not just analyzes.
Exactly. It can imagine and build new possibilities, not just react to existing ones.
Okay, that is a fundamental difference.
And the profound impact of this will be incredibly far-reaching. It'll touch everything from, say, unprecedented network automation.
Networks running themselves.
Pretty much.
Yeah.
Where networks can literally self-optimize, self-diagnose, self-heal, all the way to hyper-personalized customer experiences that don't just react, but actually anticipate individual needs.
Knowing what I need before I do.
That's the goal. It will also drive the creation of entirely new business models, perhaps services we can't even fully envision today, and foster really innovative ecosystem partnerships with other industries.
So telcos become something more.
Yes. In this new era, telecom operators will evolve. They'll go from being mere connectivity providers to becoming architects of intelligent adaptive networks that anticipate and respond to user needs in real time.
Architects. I like that.
That means they'll be building a network that literally learns and adapts to you, your habits, even your future needs, without you having to explicitly tell it anything.
Wow.
And it's crucial to stress this revolution transcends just faster speeds or greater capacity. That's part of it. But it's really about more intelligent generative capabilities. That's what will drive innovation across industries and ultimately enhance the quality of life for billions.
So connecting it to the bigger picture.
If we connect this to the bigger picture, you'll see this isn't just about, faster connections for your phone or a smoother Netflix stream.
Although those are nice too.
They are, but it's bigger. It's about building an entirely new intelligent nervous system for our digital world, making it smarter, more responsive, more intuitive than ever before, almost like a living network.
A living network. Okay, my mind is officially blown. All right, now that we understand this monumental shift, this isn't just theoretical, right?
Not at all. It's becoming very practical.
Ajit Mishra has laid out these 15 compelling, really actionable ideas that show us exactly where generative AI is going to make the biggest impact.
Yes, concrete use cases.
So we've grouped them thematically just to give you a clearer picture of generative AI's influence across different parts of the telecom sector. And we're starting with the absolute foundation, the network itself.
Makes sense. Start at the core.
Okay, theme A, revolutionizing network performance and infrastructure. In this first theme, we're going to explore how generative AI will make networks, well, smarter, more resilient, and dramatically more efficient.
The nuts and bolts.
Exactly. Imagine a network that can not only fix itself, but also anticipate problems before they even occur, preventing issues before they ever reach your device.
That's the dream, isn't it? Proactive, not reactive. 1. Network optimization and predictive maintenance.
So our first idea zeroes in on exactly that, network optimization and predictive maintenance. The solution here is leveraging generative AI to truly optimize network performance and, crucially, proactively identify and address network issues before they cause any problems for you.
Right. Moving away from that reactive, fix-it-when-it-breaks model.
To a foresight-driven one.
Precisely. And the practical use case for this is highly compelling. Imagine predictive maintenance for, say, cellular towers in a large mobile network.
Okay, thousands of those.
Exactly. Consider the sheer vastness and complexity of managing thousands, maybe even tens of thousands, of cell towers spread across an entire country, each one with intricate equipment.
Managing that manually must be a nightmare.
It's an enormous reactive undertaking. Often involves costly, scheduled inspections that might not find anything, or worse, emergency repairs after a failure has already happened and impacted service.
Right, the outage calls start flooding in.
With generative AI, that changes dramatically.
How does the tech work here?
Well, telcos leverage existing network management software, things like Huawei iManager, M2000, Nokia NetAct, Ericsson OSSRC. But now, generative AI enhances their capabilities significantly.
Okay.
For cloud platforms, you're looking at things like AWS IoT, Microsoft Azure IoT. These are crucial for ingesting and processing those vast streams of real-time sensor data coming off the network equipment.
Temperature, power usage, all that stuff.
Everything. Temperature, power consumption, signal strength, error rates. And for the core intelligence, the AML tools, you've got frameworks like TensorFlow, Keras, PyTorch.
The big names in AI development.
Right. These are powerful frameworks for building and training complex neural networks that can learn from huge data sets. They allow the system to spot subtle patterns that, frankly, human engineers might easily miss.
And the skills needed.
Your core dev skills. Python, Java, SQL are pretty essential for implementing these systems.
Okay, so how would a proof of concept work?
The process involves collecting all that real-time network data, KPIs, alarms, performance metrics from across the entire infrastructure. Then, you apply generative AI models to analyze these patterns over time.
Looking for warning signs.
Exactly. Predicting potential component failures, identifying performance bottlenecks before they become critical. And based on these predictions, the system can autonomously schedule proactive maintenance.
Oh, wow. Schedule itself.
Yes, or even dynamically reconfigure parts of the network to avoid an impending issue altogether.
So, the analysis here, the shift is massive.
What's truly fascinating is that shift from reactive break-fix to genuinely proactive intervention. For you, the listener, what this means is fewer dropped calls, more consistent speeds, a much more reliable service overall.
Because the network is fixing itself before I notice.
Before you even notice a glitch, it turns potential outages into scheduled, non-disruptive maintenance windows. And the generative aspect is key here, too. The AI doesn't just predict that something will fail. It can also generate the optimal maintenance schedule, maybe taking into account engineer availability and other planned work. Or it could even generate a temporary network rerouting plan to minimize impact while the fix happens.
So it optimizes the whole process.
Exactly. It optimizes the lifespan of the equipment, too, allows companies to strategically defer really costly upgrades until they're absolutely necessary. It transforms capital expenditure planning from, well, guesswork into precision.
That's huge for the bottom line, I imagine.
Immense. 2. Intelligent network planning and design.
Okay, that's a powerful demonstration of network intelligence. Now, building on that idea, how does this smart planning extend to future growth? It's not just managing what's there, right? How does generative AI help design future networks from the ground up?
Great question. That brings us neatly to idea number 2, intelligent network planning and design. The core idea here is that generative AI can intelligently plan and design entire networks, optimizing capacity, coverage, quality of service, all based on evolving user demands, rather than just relying on historical averages or static models.
So designing for the future, not just the past.
Precisely. A fantastic use case for this is planning and designing, say, a new 5G network for a sprawling metropolitan area.
Like London or New York, complex environments.
Hugely complex.
Yeah.
Think about the intricate balance required. You need optimal performance in dense urban canyons with millions of users, varying building structures, incredibly diverse service demands.
High bandwidth for streaming, low latency for gaming or industry.
Exactly. High bandwidth streaming, gaming, but also ultra-low latency industrial IoT applications for factories, smart traffic systems. It's a massive multivariable puzzle to ensure seamless connectivity everywhere and do it cost-effectively.
So what tech makes this possible?
Companies would use specialized network planning software tools like ATOL, Mentum Planet, Ranplan Wireless. These are industry standards for radio network design and simulation. Cloud platforms like Google Cloud and AWS provide the scalable data processing and model deployment needed to crunch vast amounts of geographical, demographic, and usage data.
And the AI part.
For the sophisticated AI, we're talking AML tools like genetic algorithms and reinforcement learning.
Okay, explain those a bit.
Sure. Genetic algorithms, in simple terms, simulate natural selection. The AI tries out millions of potential network designs, different antenna locations, power levels, frequencies, and it evolves the best ones over many generations to find optimal or near-optimal solutions.
Wow, survival of the fittest network design.
Kind of. And reinforcement learning involves training an AI agent. Think of it like a virtual network planner to make decisions by rewarding desired outcomes, like good coverage or high capacity. It learns the most effective strategies for network placement and configuration through trial and error, but in a highly accelerated simulation environment.
Learning by doing, virtually.
Exactly. And skills like Python, MATLAB, C++ are essential for the modeling and simulation work involved here.
So the proof of concept.
It involves using these generative AI models to analyze all that data. Geographical maps, building data, intricate user behavior patterns, traffic predictions, down to individual city blocks. From this, the AI generates optimized network deployment plans.
Telling them where to put the antennas, basically.
Yes, but much more. Considering everything. Antenna locations, tilt, power settings, frequency allocations, backhaul requirements, all the network parameters needed for optimal performance.
So the analysis. How intelligent can this design really be?
The real insight is how a network can be truly intelligent in its design. It's by learning from how we move, how we interact, where we use our devices most, what services we demand, and how that changes dynamically.
So it adapts to us.
It allows for creating a network that is literally designed around your evolving needs as a user base, ensuring maximum coverage and capacity where and when you need it most, even as those needs shift over time.
That's incredible.
And this ability to generate these highly complex, optimized designs that human engineers might take months, even years, to model and refine. That's the hallmark of Telecom 6.0 in action. It's faster, more data-driven, and ultimately more effective. 5. Network traffic optimization and resource allocation.
Designing networks that learn and adapt. That's mind-bending. Okay, so once a network is built, how does generative AI keep it running smoothly and efficiently day to day, especially with the wild fluctuations in demand we see?
Right. The network isn't static. Demand changes minute by minute.
So let's move to idea number 5, network traffic optimization and resource allocation. This is all about how generative AI can predict and adapt to those dynamic traffic patterns, constantly improving network efficiency and, of course, the quality of service for everyone using it.
Keeping the digital highways clear, essentially.
Yeah, exactly.
Consider the use case. Network traffic optimization for a large mobile network operator. Think about the ebb and flow of data traffic.
Rush hour evenings.
Peak hours like commuting times or evenings, major live events like a World Cup final being streamed, or sudden surges in video calls during, say, a widespread remote workday or a snow day.
Right, unpredictable spikes.
A network needs to be incredibly agile to handle these dynamic shifts without causing congestion or slowdowns for users. Traditional methods often involve over-provisioning bandwidth, which is expensive.
Just building way more capacity than needed most of the time.
Exactly. Or they react slowly to issues once they've already started. Generative AI aims to bring real-time predictive adaptability.
So what's the tech stack for this?
It includes orchestration and management systems, things like Cisco Network Services Orchestrator, Huawei U2000. These act as the sort of central brain for controlling various network elements.
Okay.
Cloud platforms like Microsoft Azure and AWS provide the scalable AI operations infrastructure needed to process these vast real-time data streams constantly pouring off the network.
And the AI models?
For the core intelligence, AML tools like LSTM and, again, reinforcement learning are key.
LSTM, what's that?
LSTM stands for long short-term memory. It's a type of recurrent neural network that's specifically designed to remember patterns over long sequences of data. This makes it excellent for time series prediction, perfect for forecasting fluctuations in network traffic hour by hour or even minute by minute.
So it sees the patterns over time.
Precisely.
Yeah.
And reinforcement learning, as we discussed, allows an AI to learn the best actions to take in a dynamic environment. So it's ideal for making real-time decisions on how to route traffic or dynamically allocate resources based on those LSTM predictions.
Got it. Skills.
Again, Python, Java, C++ are your foundational languages for the core development work.
And a proof of concept would look like?
You train generative AI models on historical network traffic data, service logs, maybe even external factors like public event schedules or weather forecasts.
External factors too. Interesting.
Yeah, anything that might correlate with traffic demand to predict future traffic patterns with high accuracy. Based on these predictions, the system can then autonomously optimize network resource allocation.
Shifting bandwidth around.
Yes, adjusting bandwidth provisioning, changing routing decisions in real time, ensuring optimal network performance before congestion actually hits.
So the analysis here, it's like the network becomes alive.
If we connect this to the bigger picture, yes. It's about the network being a living, breathing entity. One that can anticipate surges like rush hour on a digital highway and intelligently reroute traffic, adjust bandwidth allocation dynamically, all to keep things flowing smoothly for you.
And the generative part.
The generative aspect here means the AI isn't just applying preset rules. It can create novel routing paths or new resource configurations on the fly in response to unforeseen conditions, making the network incredibly resilient and efficient. 6. Predictive analytics for network planning.
That real-time traffic management is definitely a game changer for user experience, but what about the really long-term view? Networks aren't built overnight, especially massive infrastructure projects like laying fiber.
Absolutely. Those are decade-long investments sometimes.
So how does generative AI help companies look years, maybe even decades, into the future to ensure we always have the capacity we're going to need?
Right. Planning for the truly long haul. That brings us to idea number 6, predictive analytics for network planning.
Okay.
The core idea here is empowering telecom companies with sophisticated predictive analytics capabilities specifically for network planning, enabling proactive capacity expansion and critical infrastructure upgrades before demand overwhelms the existing setup.
Building ahead of the curve.
Exactly. A concrete use case would be predictive analytics for planning a fiber optic network rollout.
Right, digging up streets, laying cable. Super expensive.
Incredibly capital intensive. Laying fiber, especially cross-country or deep into dense urban centers, is a massive long-term investment. Companies need to know, with some confidence, where the demand will be in 5, 10, even 20 years to justify these huge expenditures.
And make sure they build where it's actually needed.
Precisely. Generative AI helps them make incredibly accurate long-range predictions for these major capital projects, significantly reducing the risk of either overbuilding in the wrong place or underbuilding where demand explodes.
What tools help with this long-range forecasting?
For this, you use specialized software like ESRI ArcGIS or Bentley Communications. These are industry-standard geographical information systems, GIS, and infrastructure planning tools, essential for mapping and visualizing all the spatial data.
Got it.
Google Cloud and AWS offer the scalable cloud platforms needed for the large-scale data analysis involved processing demographic, economic, geographic data for entire regions or countries.
And the AI techniques.
AML tools like random forest and gradient boosting are excellent here. They are what we call ensemble methods, meaning they combine the predictions of multiple simpler models to get a more robust and accurate result.
Why those specifically?
Random forest builds lots of individual decision trees on different subsets of the data and then averages their predictions, making it very stable and accurate. Gradient boosting builds models sequentially, with each new model trying to correct the errors made by the previous ones. Both are fantastic for handling complex, varied data sets to identify subtle, long-term trends.
Makes sense. Skills.
Your data science toolkit. Python, R, and SQL are essential skills for the data analysis and modeling in this domain.
So a proof of concept here involves...
It involves applying these generative AI models to analyze vast amounts of data. Geographical information, population density trends, socioeconomic indicators, urban development plans, historical connectivity demands, future growth projections, all of it.
Combining everything.
From all this, the AI predicts future demand for, say, fiber optic connectivity. It identifies potential high-growth areas and hotspots years in advance.
So what does this all mean for us, the users?
It means telecom companies can lay the groundwork for future connectivity before the demand explodes, ensuring that as communities grow, as new businesses pop up, your access to high-speed internet keeps pace.
No more waiting years for fiber in a new neighborhood.
Ideally, yes. This proactive approach prevents future bottlenecks and ensures a seamless digital experience for you rather than waiting for capacity issues to become a frustrating problem. 8. Network security and threat detection.
That long-range vision is clearly crucial for sustainable growth. But let's shift gears back to a more immediate and, frankly, ever-present concern: security.
Always top of mind.
In a world of increasingly sophisticated cyber threats, how does generative AI stand guard over these vital networks? Let's talk about idea number 8, network security and threat detection, more critical than ever.
Absolutely paramount.
The solution idea here is strengthening network security by analyzing network traffic patterns, identifying potential threats, and enabling proactive threat detection and response, ideally in real time.
Keeping the bad actors out.
Exactly.
Imagine the use case: real-time network security monitoring for a vast telecom network. These networks are constant targets for sophisticated cyber attacks. Everything from distributed denial of service, DDoS attempts, trying to overwhelm the network, to complex data breaches aiming to steal customer info.
And the scale is enormous.
The sheer volume of network traffic, terabytes, petabytes of data flowing, constantly makes it utterly impossible for human analysts alone to spot every anomaly or potential threat.
Like finding a needle in a digital haystack.
A constantly growing haystack.
Yeah.
Generative AI steps in to analyze these immense volumes of traffic, looking for that needle, the subtle indicators of a breach, a new type of malware, or an attack pattern that might otherwise go completely unnoticed until it's too late.
So what tech powers this digital guard dog?
On the tech side, you have leading security solutions like, say, Cisco StealthWatch or Palo Alto Networks Cortex XDR. These provide the foundational security infrastructure, the sensors, the enforcement points. Google Cloud and AWS provide the scalable cloud platforms needed for processing vast amounts of threat intelligence data and running these complex AI security models in real time.
And the AI models themselves, what's special here?
ML tools like deep learning and, again, reinforcement learning are essential for identifying sophisticated, evolving threats.
Why those?
Deep learning models, with their multi-layered neural networks, are excellent at recognizing really complex patterns in raw data, things like unusual traffic flows that deviate subtly from the norm, or recognizing malicious code hidden within seemingly normal data packets.
Finding the hidden threats.
Exactly. And reinforcement learning can be used to train an AI to act as an intelligent security agent. It can learn to identify and even automatically respond to certain types of threats by interacting safely with the network environment or simulations.
Learning to fight back, in a way.
In a controlled way, yes.
Yeah.
Python, Java, C++ are crucial for developing and integrating these security solutions.
And the proof of concept, how does it work in practice?
It involves applying these generative AI algorithms to continuously analyze network traffic, system logs, user behavior patterns, looking for anomalies.
Anything out of the ordinary.
Right. These models identify anomalous patterns that indicate potential security threats, whether it's an unauthorized access attempt, malware trying to spread laterally within the network, or a sophisticated phishing campaign targeting users. This enables real-time monitoring and allows for a proactive response to mitigate risks before damage is done.
So the analysis, what's the really interesting part?
Here's where it gets really interesting, I think. Generative AI acts like an incredibly vigilant, tireless guard. It doesn't just spot known threats by comparing traffic against a database of existing virus signatures or attack patterns.
The old way of doing things.
Right. It learns what normal network behavior looks like, the baseline for this specific network at this specific time. It can then recognize the subtle digital fingerprints of new, never-before-seen attacks, sometimes called zero-day attacks.
Attacks nobody even knows about yet.
Exactly. Even those that haven't been cataloged or analyzed by security researchers yet, because they deviate from the learned normal. This means protecting your data and your connection with an intelligence that is constantly learning, adapting, and anticipating. It makes it much, much harder for malicious actors to succeed. It's security that aims to always be a step ahead.
That's incredibly reassuring. 9. Service quality optimization. Okay, keeping us secure is absolutely paramount. But what about the everyday experience? Just using the network. We all expect our internet, our phone services to just work smoothly, reliably.
The expectation is seamlessness, isn't it?
Totally. So how does generative AI help ensure that smooth, high-quality experience? Let's turn to idea number 9, service quality optimization.
Making sure things run well consistently.
The idea here is to optimize service quality by analyzing everything: network performance data, customer feedback, both direct and indirect, service KPIs, those key performance indicators, allowing telcos to proactively address service issues and enhance your overall satisfaction.
Preventing frustration before it starts.
Right.
A great use case for this is service quality optimization for, say, a broadband internet service provider.
We've all been there: slow internet, buffering.
Nobody likes slow internet, buffering during a crucial movie scene, or dropped video calls, especially now. Traditional approaches often rely on you, the customer, reporting these issues.
Which means the problem has already impacted me.
Exactly. By the time you call, you're already annoyed. Generative AI helps providers detect the underlying issues causing these problems. Maybe congestion in a specific neighborhood network segment, maybe a failing piece of equipment miles away, often before the customer even notices a significant impact.
Turning a potential frustration into an invisible fix.
That's the goal.
What tech makes this possible?
For this, you'd use specialized network performance monitoring tools, things like Viavi Solutions Observer or XXOnova. These gather really granular data on network health, latency, jitter, packet loss, etc. Microsoft Azure and AWS provide the cloud platforms for massive data aggregation and analysis. They pull in information from countless sources: network probes, customer modems, even anonymized app performance data.
And the AI model.
AML tools such as random forest, LSTM, and time series analysis are deployed here for predicting performance degradation before it happens.
How do they work together?
A random forest helps identify complex relationships between various network metrics and the perceived quality of service. LSTM, as we discussed, is key for understanding how performance metrics evolve over time, allowing for more accurate predictions of future degradation. And general time series analysis focuses on historical data patterns to predict future trends in service quality.
Got it. Skills.
Python, R, SQL are essential again for the data processing and model building aspects.
And the proof of concept would involve?
It involves utilizing generative AI models to analyze a really rich data set.
Yeah.
All that network performance data, anonymized customer complaints, maybe even sentiment analysis from social media mentions.
Scraping Twitter for complaints.
Potentially, yes, in an aggregated, anonymized way. Plus service quality metrics. The models predict service degradation events like a specific area being likely to experience slower speeds during peak hours next week and identify the potential root causes. This allows the provider to proactively resolve them.
Fixing it before the complaints roll in.
Exactly. This raises an important question. How can a provider know you're about to have a bad experience before you actually do? Generative AI makes that possible. By continuously monitoring and learning from these vast data streams, it can spot subtle precursors to issues.
Like a tiny wobble before a big crash.
A good analogy. It allows them to intervene and resolve potential problems like buffering or slow speeds before they even impact your streaming or your video call. This proactive approach really transforms the customer experience, ideally keeping you happy without you ever having to pick up the phone or send an angry tweet.
That sounds like a much better relationship with my provider. So, okay, from building the actual backbone to ensuring its resilience and security, and then really fine-tuning our daily experience, generative AI is clearly a massive game changer for the network itself.
Absolutely. It's infusing intelligence at every layer.
It's making our connections more robust, more reliable, smarter behind the scenes, But what about our direct experience? How does this revolution impact the way you interact with your telecom provider, making those touch points smoother, more personalized?
Right, the human interface part. Let's dive into that.
Okay, Theme B, enhancing customer experience and engagement. In this section, we'll highlight how generative AI personalizes and streamlines your interactions with telecom companies, making them more intuitive, more responsive, and truly tailored to your individual needs.
Moving beyond the generic one-size-fits-all approach.
Exactly. No more feeling like just a number. 3. Intelligent customer experience management. First up in this theme, intelligent customer experience management. The solution idea is all about transforming the customer experience by analyzing your interactions, your preferences, your behaviors to deliver personalized and proactive services that truly fit you.
It's about moving from reacting to customer needs to actually anticipating them.
Knowing what I might want or need next.
Ideally, yes. A practical use case is personalized service recommendations from your telecom service provider.
Instead of those generic marketing emails I usually ignore.
Exactly. Instead of getting blasted with promotions for bundles you don't need or want, imagine receiving offers or even proactive solutions tailored to your actual usage patterns, maybe your stated interests, your past interactions with customer service.
That sounds much better.
It moves beyond guesswork and broad demographics to genuine individual understanding, making you feel, hopefully, truly valued as a customer.
So what technology enables this level of personalization?
The tech stack here typically includes leading CRM platforms, customer relationship management systems like Salesforce Service Cloud or Oracle CX Service. These act as the central repository for all the customer data.
Okay, the customer database.
Right. Then you have cloud platforms like Microsoft Azure or IBM Watson, providing powerful AI services on top of that data, especially things like natural language understanding, or NLU.
NLU.
It allows the AI to comprehend the nuances of human language, understanding the meaning behind the words in your emails, chat transcripts, or even call summaries.
Got it. And the core AI.
For the core AI, you're looking at natural language processing, NLP, and recommendation systems as the key AML tools. NLP enables the AI to process and understand all that written and spoken language from customer interactions. Recommendation systems analyze your behavior, your history, your preferences to suggest relevant products, services, or even content, much like how Netflix or Spotify suggest things you might like.
Using my data to help me, basically.
That's the idea. Python, R, and Java are essential skills for the data science work and for integrating these AI capabilities with the CRM platforms.
And the proof of concept.
It involves applying generative AI algorithms to analyze vast amounts of customer data call logs, service usage patterns, maybe website browsing history, always with appropriate privacy safeguards, of course, customer feedback from surveys or social media mentions.
Bringing it all together.
From this holistic view, the AI can generate personalized service recommendations and offers. It might predict potential issues you could face based on your usage and proactively suggest solutions. This genuinely enhances customer satisfaction and loyalty.
So the analysis here, it's about deepening understanding.
What's fascinating is moving beyond generic customer service. Generative AI helps providers understand you as an individual customer better than ever before, anticipating your needs, offering services that genuinely resonate rather than just blasting you with irrelevant promotions that feel like spam.
A more respectful interaction.
Exactly. It's about a more respectful, more intelligent, and ultimately more effective engagement where you feel truly heard and understood by your provider. 7. Intelligent virtual assistants and chatbots.
That deep understanding leads nicely to our next point, doesn't it? The tools we often interact with directly, the chatbots and virtual assistants.
Oh, yes, the front line of digital support.
We've all experienced those frustrating chatbots that just don't quite get what we're asking, right?
Yeah.
Send you in loops.
Sorry, I didn't understand that. It's infuriating.
Totally. So our next idea, number 7, is intelligent virtual assistants and chatbots. The solution here is powering these assistants with generative AI to enable truly personalized and efficient customer interactions and support, moving far beyond simple keyword recognition to genuine conversational understanding.
Making them actually helpful, not just a gatekeeper.
Exactly.
Think about the use case. An intelligent virtual assistant for a telecom customer support system. Traditionally, if your question deviates even slightly from the pre-programmed scripts, you hit a wall or you get stuck waiting for a human agent.
Let me transfer you.
Right. Generative AI is changing that. It's making these assistants genuinely helpful and intuitive, capable of understanding complex queries, remembering context from the conversation, and providing nuanced, accurate responses.
So what tech makes these chatbots smarter?
Key software includes conversational AI development platforms, things like IBM Watson Assistant or Google Dialogflow. These provide the tools to build, train, and deploy these advanced bots.
Okay.
Cloud platforms like Azure Bot Service or AWS Lex are often used for deploying and managing these sophisticated virtual assistants across various channels: web chat, mobile apps, even voice assistants.
And the AI powering them.
Natural language processing, NLP, which we just mentioned, is crucial for understanding the user's input. And conversational AI is the broader field focused on enabling human-like, multi-turn interactions. It's about maintaining context throughout the conversation, understanding follow-up questions, and even detecting user sentiment like frustration or satisfaction.
So it understands the flow of conversation.
Exactly. Python, JavaScript, and Node.js are common languages used for the actual bot development and integration work.
And a proof of concept would demonstrate.
It involves developing generative AI models that can truly understand natural language queries, parse complex sentences, maybe even synthesize information from multiple knowledge bases like billing systems, network status pages, troubleshooting guides to provide personalized and accurate responses.
Pulling info from different places.
Right. These models are then integrated with the chatbot platforms to deliver seamless customer support and assistance.
So what does this all mean for me when I need help?
Imagine a chatbot that truly understands the intent behind your question, not just the keywords you used. It can solve complex issues, like helping you diagnose a tricky connectivity problem step by step, or clearly explaining a convoluted section of your bill, or even providing detailed information about your specific plan and usage instantly.
Without needing a human agent.
For many queries, yes. This frees up human agents for the truly nuanced, complex, or emotionally charged problems that still require a human touch. For you, it means getting answers quickly and efficiently, 247 on your terms. It significantly reduces wait times and frustration, making your support interactions feel much more natural and productive.
Okay, that sounds like a definite upgrade. So it's clear that generative AI is making our direct interactions with telecom companies way smarter and much more personalized. It's really changing the face of customer service.
Transforming the front office, definitely.
But beyond the network itself and our direct interactions, generative AI is also making profound shifts in the fundamental business and operational systems that keep these huge telecom companies running smoothly.
Right, the engines behind the scenes.
These are the systems ensuring smooth operations, financial health, overall efficiency, often invisible to us as end users, but absolutely critical for the whole thing to work.
The OSS and BSS we mentioned earlier.
Exactly. So, in this final theme, Theme C, we're diving into the critical role of generative AI in that intricate world of operations support systems, OSS, the technical backbone keeping the network running, and business support systems, BSS, which handles everything from billing and charging to customer relationships and revenue management.
The operational core of the business.
We're talking about everything from combating sophisticated fraud to predicting and managing customer churn and ensuring the company's revenue streams are healthy and accurate. 4. Fraud detection and prevention. Okay, our first point in this theme, bringing it back to a really critical back-end function, is fraud detection and prevention. Idea number 4.
A huge issue for the industry.
The solution idea is how generative AI combats telecom fraud, which costs the industry billions every year by analyzing patterns and anomalies in real-time data, enabling proactive detection and prevention of all sorts of fraudulent activities.
Moving beyond finding fraud after the fact.
To stopping it as it happens or even before.
A critical use case is real-time fraud detection within telecom billing systems and network usage. Fraud is a massive multi-billion-dollar problem globally, and it's constantly evolving with new schemes.
Just like what kind of schemes?
Oh, everything. Subscription fraud using stolen identities, international call bypass fraud where calls are routed illegally, premium rate number scams, roaming fraud, device theft. The list is long and fraudsters are creative.
Always finding new loopholes.
Exactly. Generative AI provides a dynamic shield against these rapidly changing threats because it can learn and adapt to new fraud patterns as they emerge much faster than traditional rule-based systems.
So what tech is used to fight this fraud?
For this, telcos often use specialized fraud detection systems. Platforms like SubX ROC Fraud Management or FICO Falcon platform have been industry mainstays for years, but now they're being enhanced with AI.
Okay.
AWS and Google Cloud provide the highly scalable cloud platforms needed for real-time anomaly detection, capable of processing and analyzing enormous transaction volumes, billions of call records or data sessions.
And the AI technique.
AML tools like random forest and deep learning are crucial for identifying those subtle, complex patterns that indicate fraud.
Why those again?
Random forest is effective because it can handle highly imbalanced data sets very well, which is typical in fraud detection, where fraudulent transactions are usually rare compared to legitimate ones. Deep learning models are particularly adept at discovering very complex, nonlinear relationships hidden in the data, essential for spotting new, sophisticated fraud schemes that try to mimic normal behavior.
Clever fraudsters need clever detection.
Precisely. Python, Scala, and SQL are vital languages for the data engineering and model implementation needed here.
So a proof of concept would show.
It involves utilizing generative AI models to continuously analyze everything called detailed records, CDRs, billing data, network usage patterns, customer interaction histories, device information.
Looking for red flags.
Yes. These models detect and flag anomalies in real time by identifying deviations from learned normal behavior profiles for individual users, groups of users, or the network as a whole. This enables timely fraud identification and allows for automated prevention measures, like blocking suspicious calls or transactions.
So the analysis, how does it handle new tricks?
That raises the important question. How do you catch a fraudster who's always inventing new tricks, often designed specifically to bypass existing rules? Generative AI doesn't just look for known patterns from historical fraud cases. It learns what normal looks like across billions of legitimate transactions.
Establishes a baseline.
Right, and then it instantly flags anything that deviates from that baseline in a statistically significant or suspicious way. The generative aspect is interesting too.
How so?
The AI can even be used to simulate potential new fraud scenarios based on emerging trends, allowing the system to train itself against future threats it hasn't even seen yet.
Wow, training for the unknown.
Exactly. This protects both the company from massive financial losses and, importantly, protects you, the customer, from illicit activities that could compromise your accounts, your identity, or run up huge bills in your name. 10. Revenue assurance and subscription analytics.
That ability to fight evolving fraud is hugely impactful, definitely. Now let's look at another crucial financial safeguard, making sure that all the legitimate services the company provides are actually billed correctly and generating the revenue they should be.
Plug in the leaks in the bucket.
Exactly. This brings us to idea number 10, revenue assurance and subscription analytics. This idea focuses on how generative AI enables better revenue assurance and provides deeper subscription analytics by analyzing customer behavior, identifying sources of revenue leakage, and helping optimize subscription offerings.
Is making sure the business is financially healthy and fair.
Right.
The use case here is revenue assurance for a telecom operator's diverse range of subscription services. With so many complex bundles, tier pricing, promotions, usage-based charges for data or calls, and different customer segments.
It sounds incredibly complicated.
It is, and because of that complexity, it's remarkably easy for revenue to leak out. This could be through unbilled services, incorrect charges due to configuration errors, discounts applied wrongly, or even features included in plans that customers aren't using but the company still bears costs for.
Money slipping through the cracks.
Lots of little cracks that can add up to millions. Generative AI helps find and plug those gaps, ensuring every cent owed is accounted for accurately.
What's the tech stack for plugging these leaks?
The tech involved includes core billing and revenue management systems, platforms like Oracle Revenue Management and Billing, or Amdocs Revenue Guard. These are the backbone of telecom financial operations.
Right.
Google Cloud and AWS provide the cloud platforms needed for analytics at scale, allowing the telco to process and analyze vast data sets of billing records, usage information, and customer subscription data.
And the AI side?
AML tools such as decision trees and clustering algorithms are often used here for identifying customer segments with unusual patterns and pinpointing potential leakage points.
How do they help?
Decision trees can help categorize customers or transactions based on a series of rules derived from the data, highlighting pathways where revenue might be consistently lost. Clustering algorithms group similar customer behaviors or billing patterns together, helping to spot outliers or segments where billing might be inaccurate or pricing might be misaligned with value.
Finding the anomalies.
Right. Python, R, and SQL are essential again for the robust data analysis required and for generating actionable insights from these models.
So a proof of concept would involve
applying these generative AI algorithms to meticulously analyze customer usage patterns, subscription data, billing records, provisioning logs across the entire customer base, looking for discrepancies and inconsistencies.
comparing what should be billed with what is billed.
Exactly. This helps identify potential revenue leakage points, pinpointing exactly where money might be slipping through the cracks. But it also helps optimize pricing strategies and enhance subscription offerings.
How does it help optimize offers?
By analyzing which features are valued and used, the AI can help generate insights for creating bundles that are more appealing to customers while still being profitable for the company. It can identify underutilized services that could perhaps be offered differently.
So the analysis, it's about efficiency and fairness.
Here's where it gets really interesting for the business and the customer, I think. It's about ensuring that every service provided is properly and accurately billed, preventing revenue loss for the company. But simultaneously, it's about making sure subscription offerings are truly appealing and represent good value to you, maximizing perceived value on both sides.
A win-win.
Ideally.
Yeah.
The generative element allows the AI to not just find problems, but to propose new pricing models or innovative bundle configurations that are optimized for both revenue generation and customer satisfaction. It moves beyond just auditing to actively improving the business model. 11. AI-powered fault management in OSS.
Okay, so Gen AI helps secure the revenue. That's critical. But let's go back to the operational side for a moment. Specifically, the challenges of managing that incredibly complex network when things inevitably go wrong.
Faults are a fact of life in complex systems.
Right. How does AI revolutionize the way telecom companies diagnose and fix problems within their own operations support systems? Let's look at idea 11. AI-powered fault management in OSS.
Speeding up repairs and minimizing downtime.
Exactly. The solution idea is revolutionizing fault management by automatically analyzing floods of network alarms, intelligently identifying the true root causes of problems, and even suggesting optimal resolutions, enabling much faster fault resolution and minimizing service disruptions for all of us.
Cutting through the noise of alarms.
Precisely.
The use case is AI-powered fault management for a busy telecom network operations center, the NOC.
A nerve center.
Right. When a significant network issue arises, maybe a fiber cut, a major equipment failure, a software bug, it can trigger hundreds, sometimes thousands, of alarms across many different systems almost simultaneously.
An alarm storm.
Exactly. Human operators then face the incredibly difficult task of sifting through this deluge of information, trying to correlate events manually to figure out what actually caused the problem, the root cause. This can be incredibly time-consuming and stressful, especially for complex cascading failures where one fault triggers others.
Finding the first domino to fall.
A good way to put it, generative AI aims to automate and profoundly accelerate this diagnostic process.
How does the tech work here?
Core network operation support systems, OSS, like Ericsson OSS-RC or Nokia NetAct, are the systems that generate these alarms and performance data in the first place. They feed data into the AI systems.
Okay.
AWS and Microsoft Azure provide the robust cloud platforms needed for the large-scale data processing and AI model hosting required to handle the immense volume of real-time alarm data.
And the AI doing the diagnosis.
Deep learning and natural language processing, NLP, are the key AML tools here.
Why those two?
Deep learning is excellent for pattern recognition in complex, high-dimensional data. It can learn to interpret the correlations between myriad network alarms, performance metrics, and past fault signatures to pinpoint likely root causes. NLP is crucial because many alarms contain textual descriptions written by engineers or systems. NLP helps the AI understand the meaning and context within that text, which can be vital clues.
Understanding the machine's language and the human's notes.
Exactly. Python, Java, and SQL are common languages used for integration and development of these fault management systems.
So a proof of concept would show the AI.
It would involve developing generative AI models that can process and interpret huge volumes of network alarms, performance logs, configuration change data, and historical fault records. These models are trained to recognize the complex patterns and correlations that signify specific types of issues.
Learning from past failures.
Right. This allows them to accurately identify probable root causes far faster than humans often can. And then, critically, they can generate recommendations for the optimal solutions or troubleshooting steps, or in some cases, even automate corrective actions for faster fault resolution.
Automating the fix, too.
For certain types of known resolvable issues, yes.
So connecting this to the bigger picture.
Imagine the network essentially diagnosing its own illnesses, identifying the root cause, not just the symptoms, and even suggesting the cure. Or indeed, generating the precise steps needed for that cure, maybe even tailored to the specific equipment involved.
That's a huge leap.
It means significantly faster fault resolution times, much lower operational costs for the telco, and most importantly for users, far fewer and shorter service disruptions. It leads to a much more reliable service experience because the network is fixing itself with intelligent precision. 12. Predictive revenue assurance in BSS.
That's a massive leap in operational efficiency, definitely. Now, taking that same kind of intelligence, moving from reactive fixing to proactive prediction and applying it back to the financial side.
Right, applying prediction to revenue.
How can companies not just fix current revenue leaks, but actually anticipate future ones? Let's discuss idea 12, predictive revenue assurance in BSS.
Looking ahead financially.
This solution idea is about enhancing revenue assurance within the business support systems by analyzing customer usage patterns, identifying potential leakage points, and actively predicting potential future revenue risks, enabling proactive measures to safeguard those vital revenue streams.
Financial foresight.
Exactly.
The use case is predictive revenue assurance for a telecom billing system and related BSS functions. This goes beyond just finding current leakage based on audits. It's about anticipating where future revenue loss might occur.
How can it predict the future?
By looking at evolving customer behaviors, the impact of new service offerings being rolled out, potential system anomalies that haven't caused major issues yet, or even external market shifts that might impact pricing or usage. It's about foreseeing financial risks before they actually manifest as losses.
Getting ahead of the problem.
Precisely.
What tech supports this financial crystal ball?
Software like Amdocs Revenue Guard or Huawei IBSS core billing and business support systems would integrate this predictive capability.
Okay.
Google Cloud and AWS provide the powerful cloud platforms needed for the sophisticated predictive analytics, capable of sifting through massive historical and real-time billing and usage data sets.
And the AI predicting the risks.
Machine learning algorithms and time series analysis are the key AML tools for predicting future revenue trends and identifying potential risks.
How do they work here?
Machine learning algorithms can identify complex, hidden patterns in billing data, usage trends, and customer profiles that correlate strongly with potential future revenue leakage or billing errors. Time series analysis is crucial for understanding how different revenue streams normally evolve over time, allowing the system to forecast potential dips or anomalies that need investigation.
Spotting deviations from the expected trend.
Exactly. Python, R, and SQL are the go-to languages for the data modeling and analysis required in this domain.
So a proof of concept would demonstrate.
It would involve applying these generative AI models to analyze comprehensive usage data, billing records, historical revenue patterns, product catalog changes, and maybe even relevant market trends. These models then predict potential future revenue leakage and identify specific areas of risk. Maybe a new plan is likely to be misinterpreted by the billing system, or a certain customer segment shows signs of migrating usage in a way that will cause revenue dips.
Giving the finance team a heads up.
Right. This enables the implementation of proactive measures before the losses occur. Things like targeted customer engagement, proactive system audits focused on high-risk areas, or timely pricing adjustments to mitigate the predicted risk.
So what does this all mean, big picture?
It's essentially about having a sophisticated financial early warning system for the business. Companies can safeguard their revenue streams proactively, ensuring fair and accurate billing, maintaining stable services without unexpected financial hits that could impact operations, or ultimately degrade your service quality due to budget cuts.
And the generative part.
The generative element allows the AI to potentially propose proactive solutions, maybe suggesting specific changes to billing logic or generating alerts for specific configurations known to cause issues, effectively preventing these anticipated losses before they happen. It's proactive financial defense. 13. AI-driven customer relationship management, CRM, in BSS.
That's some powerful foresight for the business side. Okay, let's pivot back towards the customer, but still thinking from that strategic business perspective within the BSS.
How the business manages its customer relationships.
Right. How does generative AI transform that entire customer relationship, making it deeply personalized and forward-looking, not just reactive or based on past transactions? We're talking about idea 13, AI-driven customer relationship management, CRM, in BSS.
Making the CRM truly intelligent.
The idea here is optimizing CRM by analyzing all customer interactions preferences, behavior patterns to deliver personalized and proactive customer experiences, ultimately aiming to increase customer satisfaction, build loyalty, and reduce churn.
Moving beyond CRM is just a database.
Exactly.
The use case is AI-driven CRM for a telecom service provider. Traditional CRM is often, as you say, a somewhat static database. It holds records of past interactions, customer details, maybe some segmentation. AI aims to transform it into a dynamic living system that truly understands and anticipates individual customer needs.
Moving beyond broad segments to hyper-personalization.
That's the goal, hyper-personalization at scale.
What tech drives this intelligent CRM?
Leading CRM platforms like Salesforce CRM or Oracle Siebel CRM are often foundational here, providing the framework and the data store.
Okay.
Microsoft Azure and AWS provide the cloud platforms needed for AI-enhanced CRM capabilities, integrating powerful AI services directly into the CRM workflow.
And the AI doing the personalizing?
Natural language processing, NLP, and recommendation systems, which we've discussed, are key AML tools again here for achieving deep customer understanding and enabling personalized outreach.
How do they work in the CRM context?
NLP helps analyze all customer communications across all channels, emails, chat transcripts, summaries of phone calls, social media interactions, to extract not just topics, but also sentiment. Are they happy, frustrated, and intent? What do they really want to achieve? Recommendation systems then use this deep understanding to suggest the most relevant next best action for the company, to take maybe a specific offer, a helpful piece of content, or even proactive outreach about a potential issue.
Tailoring the interaction based on true understanding.
Precisely. Python, R, and Java are crucial skills for the data analysis and for integrating these AI models seamlessly with the CRM platforms.
And a proof of concept would show.
It involves developing generative AI models that can analyze comprehensive customer data, call logs, service usage patterns, feedback from various channels, website interactions, even publicly available sentiment if ethically sourced. This enables truly personalized recommendations for services or upgrades, proactive issue resolution where the system flags potential dissatisfaction before the customer complains, and highly targeted, relevant marketing campaigns instead of generic blasts.
So the analysis, CRM becomes an engagement engine.
What's truly fascinating here is how generative AI transforms CRM from mainly a record-keeping system into a dynamic, personalized engagement engine. It aims to build stronger, more resilient long-term relationships with you, the customer, by understanding and anticipating your needs, almost like a dedicated personal assistant who knows what you want, sometimes before you even ask.
Fostering loyalty through relevance.
Exactly. Fostering loyalty by consistently delivering relevant value and showing genuine understanding. The generative component is powerful here too.
How so?
It allows the AI to actually craft unique messaging, personalized email content, or specific offer details tailored just for you, based on its deep understanding. It's not just picking from templates, it's generating personalized communication at scale. 14. AI-based network capacity planning in OSS.
That's a profound shift towards really understanding and valuing the customer. Okay, let's look at another critical operational challenge back in the OSS world. Making sure the network infrastructure itself is always perfectly aligned with demand.
The capacity planning challenge. Always tricky.
How do you build a network that's always just right in terms of capacity, avoiding both wasteful overbuilding and frustrating underbuilding that leads to congestion?
Finding the Goldilocks zone for network capacity.
Exactly. That brings us to idea 14, AI-based network capacity planning in OSS. The solution idea is optimizing network capacity planning by analyzing historical traffic patterns, predicting future demand with high accuracy, and recommending the most efficient resource allocation strategies, ensuring optimal network performance and cost efficiency.
Making smarter investments in infrastructure.
Right.
A very relevant use case is AI-based network capacity planning for a major telecom operator, facing decisions on where and when to invest billions in network upgrades, maybe deploying more 5G spectrum, densifying the cell grid, or expanding fiber backhaul.
Huge decisions with long-term consequences.
Absolutely. Building too much capacity or building it in the wrong place is incredibly wasteful of capital, leading to underutilized assets just sitting there. But building too little or too late leads directly to network congestion, slow speeds, and very frustrated customers who might leave.
A difficult balancing act.
Finding the just right balance is incredibly complex, especially with ever-changing data demands from new technologies like VRR, IoT, and constantly shifting user behaviors.
So how does AI help find that balance? What's the tech?
Network management and orchestration tools like Huawei iManager M2000 or Cisco Network Services Orchestrator provide the real-time data feeds on network performance and current usage levels.
Okay.
Cloud platforms like AWS IoT and Microsoft Azure IoT can provide robust data collection and processing capabilities specifically geared towards capacity planning, gathering metrics from every corner of the network infrastructure.
And the AI doing the planning.
Machine learning models and genetic algorithms are key AML tools for the complex optimization required in resource distribution and planning.
How do they apply here?
Machine learning models excel at learning from historical traffic data, demographic shifts, and other factors to forecast future demand in specific geographical areas with high accuracy. Genetic algorithms, as we discussed for network design, are fantastic for exploring a vast solution space of potential upgrade options, what to build, where, when, to find the most efficient and cost-effective strategies that meet the predicted demand.
Finding the best investment plan.
Essentially, yes. Python, Java, and SQL are foundational skills for the data-driven planning and automation involved.
So a proof of concept demonstrates the AI.
It involves utilizing generative AI models to analyze historical network traffic data, customer growth projections for different areas, demographic shifts, the impact of new housing developments, planned business openings, and emerging technology trends that might drive new types of usage.
A very holistic view of demand drivers.
Exactly. These models predict future demand patterns, often with surprising granularity. And then, critically, they generate optimal resource allocation strategies.
Like telling the engineers what to build.
Precisely. Generating recommendations for specific network upgrades, suggesting targeted capacity expansions in particular neighborhoods or along specific transport routes, or even proposing dynamic reallocation of existing resources like spectrum to meet shifting demands more efficiently.
So the big question, how do you build that network that's always just right?
Generative AI provides the intelligence to get much closer to that ideal. It helps prevent both costly overbuilding, which wastes resources, and frustrating underbuilding, which leads to congestion and poor user experience. It aims for ensuring optimal performance and cost-effectiveness for everyone, benefiting the operator's bottom line and ensuring a seamless, reliable experience for you as the end user. 15. AI-driven churn prediction in BSS.
That perfect balance of capacity is definitely a huge win for everyone involved. Okay, finally, let's close out our 15 ideas with a really powerful application focused squarely on customer retention, arguably one of the most vital aspects of any subscription-based business like telecoms.
Keeping the customers you have is usually cheaper than acquiring new ones.
Absolutely. So we're talking about idea 15, AI-driven churn prediction in BSS. The solution idea is enabling highly accurate churn prediction by analyzing customer behavior, usage patterns, interaction history, and even sentiment analysis, allowing telecom companies to identify customers who are at risk of leaving.
And implement proactive retention strategies before they actually decide to switch providers.
Stopping churn before it happens.
Exactly.
The use case here is churn prediction for a telecom service provider. Losing a customer, as you said, is incredibly costly. There's the lost recurring revenue, obviously, but also the significant marketing and sales expense involved in acquiring a replacement customer. Makes sense to focus on keeping existing ones happy.
Immensely valuable. So identifying those customers who are at risk of leaving, maybe due to dissatisfaction, maybe due to a competitor's offer, maybe just changing needs before they actually make the jump, is crucial. Generative AI makes this identification much more accurate and allows for highly personalized intervention strategies.
How does the tech identify potential churners?
For this, analytics platforms that focus specifically on customer insights are vital. Tools like IBM Watson Analytics or SaaS Customer Intelligence often play a role here. Cloud platforms like Azure Machine Learning or Google Cloud AI provide the scalable infrastructure needed for deploying complex machine learning models and processing the vast amounts of customer data required.
And the AI models doing the predicting.
Machine learning algorithms and natural language processing, NLP, are the key AML tools.
How do they work for churn?
Machine learning algorithms build predictive models that learn from historical data of customers who did churn versus those who stayed. They identify complex patterns in usage data, example, declining usage, specific types of service issues, billing history, example, frequent late payments, interaction logs, for example, multiple unresolved support calls that correlate strongly with the customer leaving. Natural language processing is crucial for sentiment analysis.
Analyzing the tone of interactions.
Yes, analyzing the emotional tone detected in call transcripts, chat logs, or even social media comments related to the provider. Gauging satisfaction levels directly from their words can be a powerful predictor of churn risk.
Combining behavior and sentiment.
Right. Python, R, and SQL are the essential languages for the data science work involved in building and validating these predictive models.
So a proof of concept shows the AI.
It involves applying these generative AI algorithms to analyze comprehensive customer data, detailed usage patterns over time, call logs, billing history, support interaction frequency and outcomes, and importantly, customer sentiment derived from all those interactions. These models are trained to identify subtle churn patterns and predict each individual customer's likelihood of leaving within a certain time frame.
Giving each customer a churn score, basically.
Effectively, yes. Based on these predictions, the system can then trigger targeted retention strategies.
Like what?
Maybe a personalized offer tailored to address their specific usage needs or pain points. Maybe proactive outreach from a specialized human retention agent to understand and resolve their issues. Or perhaps tailored service adjustments or credits. The key is intervening proactively and relevantly.
So the analysis, reading the tea leaves.
What's fascinating here is that ability to almost read the tea leaves of customer behavior and sentiment. Generative AI helps providers identify you specifically if you're showing signs of being at risk of leaving. It allows them to reach out with personalized offers or solutions before you even start seriously considering switching providers.
Making you feel valued enough to stay.
That's the aim. This leads to a more stable customer base for the company, allows them to focus resources on improving service rather than just constantly replacing lost customers, and ultimately, hopefully, results in a more responsive and caring provider for you. So yeah, as we've seen across all these 15 ideas, generative AI isn't just touching one isolated part of the telecom world. It's truly being interwoven into every single layer.
From the deepest infrastructure.
Right, from the physical network infrastructure and its deep-seated operational systems like OSS and BSS.
All the way to the customer's final interaction and the overall business health.
Exactly. It's incredibly comprehensive. And it represents a really profound, intelligent transformation across the entire sector. Moving it firmly, I think, into this new era, Ajit Mishra calls Telecom 6.0.
Ajit Mishra's vision for Telecom 6.0, powered by generative AI. It truly highlights a monumental shift, doesn't it?
It really feels like a paradigm change.
It's clear that generative AI is no longer some distant aspiration or, a futuristic concept for telecom companies. It's rapidly becoming an absolute imperative.
A necessity to stay competitive and relevant.
And profoundly impacting everything, from the complex operations of the network backbone right down to your personal connection and every single interaction you have with your provider.
It touches all points.
We've seen how it streamlines operations, how it dramatically optimizes resource utilization, enhances network security, vastly improves customer experiences by making them personal, and even maximizes revenue for providers in smarter ways.
And all of that.
All of which ultimately should translate into better, more reliable, more secure, and definitely more personalized services for you, the end user.
Indeed. And if we just connect this back to the bigger picture one last time, it really underscores how the future of telecommunications goes way beyond just incremental improvements in, say, speed or capacity. Those will happen, but
that's not the main story.
Right? The main story is about creating intelligent, adaptive, even self-organizing systems.
Yeah.
Systems that don't just react to commands, but actively anticipate and respond to needs. It's making our networks far more intuitive, much more efficient, and ultimately more responsive to us, to human needs.
It's not just technological advancement.
No, it feels like it's fundamentally rethinking how our entire digital world is built, how it's maintained, and how it will ultimately serve us better in the future.
A fascinating prospect. Okay, before we sign off, if you found this deep dive valuable, and we hope you did,
please let us know.
Please show your support. You get the drill, like this deep dive. Maybe comment with your thoughts on Telecom 6.0. Which of these generative AI applications do you find most impactful, or maybe even a bit scary?
We'd love to hear your perspective.
And of course, please subscribe to our channel on YouTube, that's at CAIO Zone or CAIO Playbook, and on Spotify to catch all our future explorations into these transformative technologies.
Your engagement really does help us keep bringing you these kinds of deep insights.
It absolutely does. And maybe just a final thought to mull over as you go.
Ooh, a provocative one.
Hopefully. If generative AI can make networks truly anticipate and adapt to our needs with this kind of intelligence and foresight we've been discussing, what new forms of digital interaction, what entirely new services, what kinds of human connection might Telecom 6.0 unlock that we can barely even imagine today?
That's a big question, the possibilities.
They feel pretty limitless, right? Thank you so much for joining us on the deep dive. Until next time, keep learning, keep exploring.